Welcome everyone to the fourth edition of SEMLA, which is Self-Engineering for Machine Learning Application Symposium. As you may know, SEMLA is a forum that's what's built to provide a space to allow experts both in software engineering and machine learning to meet and discuss about the challenges of engineering software systems that include machine learning and AI. So machine learning models are now ready from prime time, as we all know. They come with additional challenges that in some ways force the software engineering community to rethink some of the processes and the techniques that we have been using over the past 50 years of our history. So it's an important moment in time, and so we build SEMLA to have this conversation from both sides of the community to strengthen our techniques and provide tools and methodologies and techniques to build trustworthy AI-based, in particular machine learning-based software systems. So it's really here at the intersection, and the goal is really to foster discussion. Previous edition of SEMLA were on premise at Polytechnique Montreal for those who will bless us with their participation in the first 2 years. But as you know, since we have been in a pandemic for almost more than a year now, the past 2 editions of SEMLA have been a webinar series. So last year we ran a webinar series that actually attracted across the 3 weeks almost 1,000 participants. So that was very, very encouraging number, very exciting thing to notice at the end. We hope you will find this series that we have prepared for you as exciting as the one of last year. So we'll be running from today to July 1st. We have 6 exciting webinars coming, and we're looking forward to meeting as many of you as possible to join the discussion. So we're the organizer. From the beginning, SEMLA have been organized by the computer science department, in particular the software engineering team at Polytechnique Montreal. So these are the people behind the organization. We have Professor Giuliano Antonio, Professor Jingui Cheng, Professor Focares, Professor Hamdaka, myself, and Professor Lee. The team have evolved a bit over the years, but roughly we have been the same team organizing SEMLA. So we hope you find the effort useful. So this year's series is composed of 6 webinars of a diversity of topics. So we picked the topic based on, we think, the importance, the relevance for the engineering of AI-based systems, and also to cover as more diverse compared to previous edition of SEMLA. So our first speaker today will be Professor Shneiderman. So we're very lucky to have him. He will be talking about human-centered AI. The second talk will be done by Nishi Talagala. She will be talking about how AI is actually making inroads and impacting workforce that are not necessarily traditionally prepared to deal with AI-based systems, and all the effort that is being done and that we can do to enable a broader access to AI-based systems, which is call it AI literacy. The third talk will be about explainable AI. So we'll benefit from Liao from IBM. She will be talking about these exciting topics. Then we'll be discussing continued delivery for machine learning system with 2 experts from ThoughtWorks. They will present their recent work on this space, and I'm very much looking forward to this webinar as well. And then we'll be benefiting from the perspective of Microsoft Azure by Nino. That we'll be talking about AI ops, how they have been leveraging AI and machine learning in production to improve the reliability of systems, and how they have been doing maintaining those AI-based systems that they are using in production. And then finally, on July 1st, we're having a very exciting talk by Grace from Carnegie Mellon. She will be talking about the architecture. Right? How do we architect systems that include this AI-based component? So in some 6 very exciting webinars coming ahead, I hope you're as excited as I am. And without further notice, I will pass to Jingui, who will be moderating our very first seminar 2021. Please, Jingui.
Thank you, Foots, and welcome everyone. Just a few notes about logistics. If you have any questions to the speaker, please use the Q&A function of Zoom to ask the questions. And even during the talk, you can ask the questions, and also make sure to vote on the questions if you see something that you would like to get answered. And at the end of the talk, I will relay the questions to the speaker in the order of their popularity. So please do use the Q&A function to ask questions to the speaker. So today we're very excited to have Ben Shneiderman to talk to us about the intriguing topic of human-centered AI. Ben really doesn't require a lot of introduction because in the field of human-computer interaction or anything related to user interaction should have already know him because he's really one of the founding fathers of the entire field, HCAI. And if you don't know Ben yet, I think the above introduction is sufficient, but I will add a few sentences. Ben is an Emeritus Distinguished University Professor in the Department of Computer Science, founding director of Human-Computer Interaction Laboratory at the University of Maryland. He's a fellow of AAAS, ACM, IEEE, and AI, and the Visualization Academy. He is also a prolific writer of many articles and books. His book, Leonard Laptop, won the IEEE Book Award for Distinguished Literary Contribution, and he will have an exciting book to be published in 2022 on the exact topic of human-centered AI. And I think this is a topic that is kind of both old and new to Ben and to a lot of people working in HCAI. Without further ado, I will pass the mic to Ben. Thank you very much for coming, and we really look forward to the talk.
Thank you very much. Really wonderful team and great lecture series, and I'm pleased to be starting that lecture series out. So as you can see by my background, I'm in beautiful Vancouver and not in Maryland, and I've been here during the COVID times, and it's been a good choice to be here. So I'm pleased to join the group at Polytechnique of Montreal and talk about human-centered AI. So let's go to the slides and share my screen. Here we go. All right. That gets you. Right. Okay. So the topic for today, human-centered AI, about software engineering aspects of how we build reliable, safe, and trustworthy systems. And I'm very pleased that the SEMLA tagline says trustworthy in it. That's the key message. How do we get there? It's not easy, but there's a lot to be done, and there's a big role for software engineers to play in that. So from my background, I'm in the Human-Computer Interaction Lab at the University of Maryland, now on its 8th director after 38 years in an interdisciplinary group between computer science and the rapidly growing College of Information Studies, plus other groups around campus, including the Maryland Institute for Technology and the Humanities, MITH. There's 1,000 tech reports and 200 videos on our website and a lot more information. I hope some of you know me from my book, Designing the User Interface, now in 6th edition, requires 5 co-authors to tell the story of the remarkable growth of this field, the theories, the practical approaches, and the design issues that are faced in making the mobile devices and all the technologies work for people, and the idea of the design strategies and then the evaluation mechanisms as well. My own work, some of my claims to fame, sometimes small ideas have very powerful impacts. And the idea of the link was our work in 1984, 5, 6. And the light blue color was designed by us and tested. We tested many colors, including bright red. Red was more visible, but we found that users who could spot the links did not remember the text that they were reading as well. And so the light blue is what we adopted, and it's what Tim Berners-Lee saw, and he put in his Spring '89 manifesto for the web. So these ideas of embedded menus came from a very simple idea. Also, a simple idea was touchscreen keyboards. We were working on design of small keyboards. At the time, 9-inch keyboards were the standard, and we made a 7 and a 5, and then a 3-inch keyboard by putting your finger down, getting a cursor, which you could slide back and forth, and then it activated on liftoff. Steve Jobs visited our lab in October 1988, and I became a consultant for 5 years for Apple, and that's part of how this technology became part of the Apple systems. I hold a patent on photo tagging, where you would drag and drop names onto photos, and that became another one of those small ideas that traveled well. But most of my career has been spent on visualization and more complex tools for analysts. Spotfire was our work from the mid-90s. Company was formed in '97 and grew to 200 people and was sold in 2007. It remains one of the leading tools and was the initiator of developing these multiple ideas of the double box dynamic query sliders, the multiple coordinated windows, brushing and linking. Our friends at Tableau started afterwards, and Tableau has become a huge success, but Spotfire remains strong and a commercially successful tool today. Also the developer of the tree maps, here showing the stock market with 500 stocks. The area for each company is the market capitalization. So the big ones like Microsoft, Apple, Amazon, Google, or Facebook, and the color shows the change from the previous day. Green means it's up and red means it's down. You can detect anomalies inside industry clusters, and you can see which sectors had better or worse performances. We also developed NodeXL tool for network analysis and visualization. It's the most widely used tool for teaching network analysis and visualization, and our book is now in second edition about using NodeXL. There is a free version, and there's also an academic version as provided by the Social Media Research Foundation. Event flow is another 10 years, our most recent work about sequences of event analysis, which can be used for software engineering, commits, for example, GitHub commits, and other kind of ways where there's sequences of time-stamped events and you want to study them. This shows hospital data and the performance of emergency room teams. And it was revealing because only the first half of the teams did the right thing in the emergency room. So that's become a popular and much imitated, much copied idea of doing event sequence analysis. But today is a different story. So today is about human-centered AI. And as Jingwei Cheng said in the introduction, my background and emphasis has been human-computer interaction. And I have in the past been a critic of AI, but I've come to see, its value, its power has been clearly established. The benefits are there, but I think taking a human-centered approach will bring it to the next level, because there are, of course, many problems with AI systems as well, and that doesn't always work out as expected. It has surprises to it. And the strategies of machine and deep learning make it somewhat more unpredictable. So the challenge is, how do we get there? Well, what do we mean by human-centered AI? And I'd say simply, it revives old ideas, brings them together, wants to amplify, augment, empower, and enhance people. So while AI is very strong in measuring and evaluating the performance of algorithms, is one algorithm better than another algorithm for ImageNet recognition applications or for natural language translation? In the world of human-centered AI, we're interested in evaluating human performance. Does human performance get better when we make certain improvements to the system and to the design? So that's where we're going. And I'll just lay this out step by step. The highest level of aspirations of human values, we want to make systems which make the world better for people. We want to improve human rights. We want to support access to justice. We want to support human dignity. Those are strong goals that are part of being human-centered. We think about people first. Well, we also think about individuals and what do we want to provide them when we build reliable, safe, and trustworthy. We want to make them we want to build their self-efficacy, support their creativity, clarify their responsibility, and facilitate their social connections. Those are really the goals that we think about for individuals. For the design of the systems we're talking about, I repeat, the reliable, safe, and trustworthy. And I've addressed that at 4 levels. The team structure of software engineering teams, and I'll focus on that in the talk today. The organizational design notions of safety cultures, the industry-wide efforts of certification, evaluation, and the government efforts at regulation. And we'll just mention those briefly. Now, when we think about systems, since we're thinking about human-centered, we're thinking of the stakeholders. And there are about 25 top terms we could use, but I chose these 5 to represent the researchers and the students and the postdocs, the developers and the implementers, the business leaders and the managers, the policymakers in government and in industry groups, and the large numbers of users. So that's who we think about. And when we talk about any design aspect, we need to think about which of those stakeholders are we building for, okay? At the same time, we have to remember something software engineering is very good at doing, the threats from malicious actors, the adversarial threats of people who wish to attack. The ransomware stories of recent days give you an idea of what the threats are. The bias that could come from the data or from the programming, and the flawed software that may not be doing what the designers expect that they're doing. So at every point, we need to keep the threats in mind as well. And in the presentation, there's 3 approaches to dealing with this, 3 fresh ideas. These are the foundation for the book. There's the HCAI framework, I'll talk about briefly, which opens up thinking from the traditional view that says, if you have more automation, you have less human control. My belief is you can have high levels of human control and high levels of automation. That's the secret. The second will be to shift the design metaphors away from the old-fashioned ones, which suggest computers are intelligent agents, our teammates, partners, collaborators, or social robots, and to talk about the super tools, active appliances, telebots, and control centers. I hope that new language will be useful to you when you describe and design the systems you build. And then the governance structures, which will be put in place at the 4 levels I suggested: the team, the organization, the industry, and the government. This is the basis of what I've been working on for the last 2 years. The book is in production with Oxford University Press and will appear in January 2012. My website talks about it and gives a table of contents, so I'm working quite actively about it. At the end, I'll give you more information about how you can learn about these ideas. So if I jump to the metaphors, I suggested the super tools would be such things as your digital camera. You get enormous degree of control over the system. You can choose many features before you take the picture. After you take the picture, you can make adjustments. You can do so many different things. At the same time, there's a high degree of machine learning and AI techniques built in. It chooses the focus, sets the aperture, reduces hand jitter, does many other services, not only while you're taking the picture, but afterwards, organizing the photos and recognizing faces and grouping photos and presenting the information in a reasonable way. So I'd like to call these super tools. And it conveys the sense of tool-like behavior, which means the user is in control. The user gets to point the camera where they want to, zoom in on what they want to, and then click for the decisive moment when they get the picture they want. It's their photo. They made the photo. They feel proud of it. They take credit for it. They share it with other people, okay? It's socially facilitating as well. And that's an excellent form of design, okay? Similarly, things like Google or Apple Maps. Here is an example of from the White House to the University of Maryland. It's just a short way, just 8 miles. And the GPS navigation system gives me 3 choices. That's the right idea. Give the user choices and let them select, and then they can choose which path they want, and then they can, during the execution, control what happens. They also can choose whether they go by car, by bus, or they walk, or bicycle. I find it really impressive that it provides this information, and it's up to date, it's current. It shows traffic conditions at the time you do it. So it has the best of AI, of machine learning, data analysis, recommender systems, and it has the high degree of human control that makes you feel this is your trip. Similarly, other applications we've come to learn, the use of search query completion, where I start typing University of Maryland, and it gives me a variety of choices. And then spelling corrections are the same. It gives the users choices, but preserves user control. That's the central idea of super tools. And here's an extreme version, Bloomberg Terminal. I've lately had the pleasure to learn more about it, and it's very impressive. Bloomberg takes in 1.6 million articles on business every day, and the machine learning natural language processing algorithms sort them out, organize them, cluster them, present them in ways that are relevant to what the user wants. At the same time, you can see the good sense of design here of spatially stable, non-overlapped, that is tiled displays, information presented to the user in the form they wanted. They can rearrange it, but it provides a huge amount of information very rapidly, giving the user a sense of power, of super tool. Yet, again, there's a high degree of AI. Active appliances are becoming the other growing area. All the appliances around our houses are getting to have more and more software, machine learning, and so on. The Nest thermostat, or your dishwasher, the clothes washer, even your coffee maker is getting machine learning chips in it to adjust the coffee to be just right for you. And so we're seeing the movement of that, but the design of these is also very human-centered. So active appliances are a big part of the idea. We might also think of active appliances as things like the implanted cardiac pacemakers. We used to think of it as an autonomous device put into your body and it operates independently, but increasingly users have control by way of their iPhones or Android devices, and so do the clinicians who supervise them. So we're getting to see a very different perspective as devices shift. Similarly, we might go to the third category of telebots. I call them tele-operated devices. And you could certainly provoke a discussion with NASA engineers whether the Mars rovers are autonomous, which some will say, or whether they're teleoperated. But the fact is, there are these large control rooms at NASA's Jet Propulsion Lab where many people operate the Mars rover. It has a great combination. It's autonomous in that it can move forward, avoid obstacles, avoid precipices, yet the human operators are in control of what it does at a grander scale. They're also available to deal with problems that arise. And so that beautiful blend between having the AI machine learning facilitation, but having a strong degree of human control. And I might make the point that this overturns the 40-year-old model that, 40-year-old model from Tom Sheridan, which was called levels of automation or levels of autonomy, which went from 0 to 10. And the belief was at the time that it was a zero-sum game, that the more automation you had meant you had less human control. And that's what I'm trying to break out of. I want to have a vision where you can have high degree of human control for the things the humans care about and high degree of automation for where the machine learning AI systems can be effective, reliable, safe, and trustworthy. That's the blend to look for, not one or the other, but both. High levels of human control and high levels of automation. Further example, the Telebot, which is the Da Vinci surgical system. Often you'll see newspaper headlines about robotic surgery does better than human surgery. Well, as the manufacturer says, robots don't perform surgery. Your surgeon performs surgery with Da Vinci by using instruments that he or she guides via a console. Again, an excellent combination of technologies that allows surgeons to operate with great precision at very difficult to reach places within the human body, enabling for safer operations and that are more effective in many cases. And I think the evolution of these telebots are driving a lot of new technologies. Finally, the control center idea. The hospitals are increasingly having, for many of the devices, like patient-controlled analgesia, intensive care units, there may be a central control room that watches over everything. And the control center idea is the fourth big idea about designing the new metaphors. So what we want essentially is air traffic control for every robot, or for every self-driving or safe driving car. I prefer to use the term safe driving than self-driving car. Similarly, many control centers in utility companies, transportation centers, counterterrorism give us further example of what the designs of the future will be. High amounts of visual information presented, enabling people to work closely together and collaborate with each other, yet sharing information and having a great deal of information available for them to make decisions. So I'm a great believer also in visualization and in presenting a great deal of information in a compact, well-organized, meaningful way. That's the challenge for us as designers. So let me turn to the 15 recommendations about the governance structures, and it's in 4 ovals. So the team, software engineering team, and I'll concentrate on this for this talk, allows for software engineering practices, which we'll come to, but the software engineering teams, there may be many software engineering teams in an organization, and the organization leader will then be the responsible person to establish a safety culture. And the aspects of safety culture are the leadership commitment, the vision statements, hiring and training the right people, and giving them adequate training, the study of failures and near misses, the companies, software companies included, which keep a record, a one-page sheet of the most common bugs in that organization, have a much better record in producing on-time and successful software. The internal review policies and the industry standards. The next oval is of the industry that contains many companies working in medicine or transportation or construction industries. And here we have the social processes and the business processes of auditing firms like KPMG, PwC, Ernst & Young, Deloitte, which have for many years provided good service in auditing financial aspects of companies. They're stepping out now to audit the AI systems of those companies as well. Insurance companies are also a potential opportunity for making better software engineering and machine learning systems. So the question you should ask yourself is for self-driving cars, or let's say the Tesla car. And I just might ask you the question, think for a minute, how many deaths do you think there have been from Tesla cars or involving Tesla cars? Well, I think, when I first was asked that question, I thought 3, 5, 10, maybe 15, but there's a website called tesladeaths.com, tesladeaths.com, which last time I looked had 182 deaths from Tesla cars. Now, we don't know how many of them were caused by autopilot, and we don't know the details, but because all these reports are taken from newspapers and websites around the world, and so they tend to be incomplete. It's possible that Tesla knows, but they're not telling. And so we don't have enough information, and the insurance companies are confused. I've spoken with them, and they're not sure. The question would be, would insurance companies charge a higher premium for self-driving cars, which would send a very scary signal, okay, to the developers and the public, but maybe it will be a lower premium for self-driving cars because they are safe. For the moment, we don't really know, okay, but that's the kind of data that will guide the trustworthy certification of these tools, and where other organizations, Consumer Reports, Underwriters Laboratory, will develop standards and ways of dealing with it. And the IEEE P7000 series of standards that's emerging now about machine learning and AI will also contribute to it. Finally, there's the outer oval of government regulation. Many in industry have been resisting regulation, arguing that it would slow innovation. Yet there's a change in mood. Facebook has begun to ask for regulation. And there's an awareness that regulation can also bring innovation, as it did in the automobile industry for fuel efficiency and car safety. The government requirements for safety and fuel efficiency led to enormous innovation in the industry in design of cars. Okay, so this story is covered in the ACM Transactions on Interactive Intelligent Systems, the October 2020 issue, and it's open access. You can take a look at the greater description of that. But I'm going to focus for the remaining 10 minutes or so, and then we'll have time for questions, on the team aspects of software engineering. So there's 5 recommendations about reliable systems based on software engineering practices, and I will focus on 2 of them today, but you can read up more about the others. I'll just mention numbers 2, 3, and 4. The software engineering workflows, Microsoft and Google have each published interesting new forms of the workflow for software engineering, which adjusts the agile styles of the past to accommodate the needs of data collection, data verification, and also program verification and validation. And the strong issues of concern about bias testing to improve fairness. It's triggered in the last 7 or 8 years thousands of papers about the ways of improving fairness. So my focus in the remaining minutes will be audit trails and explainable user interfaces. And the audit trail idea comes to us from civil aviation, which has become very safe because of flight data recorders, voice cockpit recorders. And the idea would be to generalize that in a flight data recorder for every robot is the idea, or every AI machine learning tool. So the original purpose of flight data recorders was retrospective analysis of failures. The National Transportation Safety Board was responsible for flying in when there was an aviation crash or train or car or a ship crash. And they would get the flight data recorder, and they had software tools for analyzing the flight data recorder to understand what went wrong. Okay. Now, this has proved to be a very successful strategy in aviation, but its generalization to other areas is slower. There are data recorders for trucks and for cars and for some other devices, but here's a software engineering research and development challenge that I hope this community would pick up on. If you do Google search or Google Scholar search on flight data recorders, you'll find lots of patents, but very few research papers. And I found resistance in the robotics community. I've approached 4 sets of technical program chairs and 1 journal editor requesting that they add to their list of topics the idea that there would be analysis of flight data recorder or audit trails and analysis tools. And they dismissed that. And that's disturbing to me. I hope this community, the SEMLA community, would take that on as a primary topic. What should go into an audit trail for medical devices, for transportation, and so on? What should go on a Tesla or other self-driving cars? The National Transportation Safety Board report on the 2016 Tesla crash, a very readable 60-page document. I encourage you to take a look at it. But among its 13 recommendations was improvement of the audit trails, because in truth, they could not fully reproduce and understand what went wrong. And so they had some recommendations for improving audit trails. But it's a substantial software engineering challenge to figure out how much data to collect, what to collect, and then what kind of software tools you need to analyze it so that you can understand the failures. So you should know when a 777 crosses the Atlantic, it generates about a petabyte of data. It's a huge amount. And so the analysis tools have to be good enough to distill that and to allow the analysts to dive deeper. So that's my strong encouragement for research topics, for faculty, for students in software engineering. What do we mean by a flight data recorder for every robot or every machine learning tool? It turns out that beyond the retrospective analysis of failures, which began 40, 50, 60 years ago, that 2 further benefits have come into play as these logs or flight or data recorders, audit trails have come into widespread use. First, you can understand the near misses. If pilots have done something to prevent a crash, that's really interesting. So you want to be able to understand and analyze what's going on when things have gone right, okay? And that turned out to be a very important feature to change training, in fact, to improve the design of the technology. The other surprising benefit that emerged in the last decade or so was that MITRE Corporation began to become the repository for the flight data recorders for every flight, and their analysis began to lead to a better understanding of what was needed to support preventive maintenance. So for each kind of aircraft, what were the failure signals for engines or for airframes? When did vibration begin to increase? When did structural failure become a potential danger? And so there are real potentials. It's a wonderful source of information. Okay, so that's the audit trails. I promised one more topic, which is the explainable user interfaces. And that's a huge topic in the last 6 or 8 years, in part promoted by the European GDPR, General Private Data Regulation principle. And so it guaranteed an explanation for users of systems. And the work here has focused on the huge amount, thousands of papers, on retrospective analysis or so-called post hoc analysis. And the discussion often was a local analysis of why a particular mortgage was rejected, or why a particular hiring was turned down, or academic application for a university, or global explanations about how the system itself worked. There's a DARPA HCAI, Explainable AI project with 11 projects within HCAI program with 11 projects in it. And a lot of papers have come forward in this area. But there's a growing awareness that this is not working out. And in fact, these retrospective explanations, I'm quite troubled. I haven't seen one that I really like yet. I've been searching for the purposes of the book for screen prints of good versions of retrospective analysis. If you know of one, send it to me, please, okay? And the emerging new goal is to prevent the confusion and surprise that generates the need for explainability. Cynthia Rudin, in a compelling paper in Nature Machine Intelligence, says, stop explaining black box systems. And her approach to preventing confusion is to have systems whose design, whose model is clear enough that you understand it from the beginning. My approach is a little different. I suggest prospective user interfaces, design of visual user interfaces that are interactive, exploratory, and let users find out what's going on so they don't wind up in confusion. It's a progressive approach that you see in many applications, from Amazon checkout to TurboTax and so on. I'm going to choose a very simplified model, an example of a post hoc report for mortgage loans, okay? So you might have this is a typical post hoc approach. You enter the amount you need for the mortgage, your household monthly income, your liquid assets. Again, a very simplified model of this. You click submit and you get a result. And it says, we're sorry. This is an example of what's a good post hoc explanation. Your mortgage loan was not approved. You might be approved if you reduce the mortgage amount requested, increase your household monthly income, or increase your liquid assets. Well, that's a pretty good direction for actionable change, but you really don't know how much do you have to reduce the mortgage amount or increase the monthly. Was I really close or was I far away? And so the alternative strategy, a prospective user interface, would give you sliders. Whoops, sorry. Sliders which would allow you to change the amount requested, and that would show you your score. And as you move the mortgage amount to a lower amount, your score would go up closer to the score needed for approval. Your household monthly income, if you increase that, you get more blue. If you increase the liquid assets, you get more blue. And so you can explore the model and understand what it's going to take for you to get a mortgage. Okay, so that's the basic strategy, and there are about 25 studies that show this really works. A delightful example for lightweight recommender systems are the British site set up by a group of charming librarians that I've been in touch with called whichbook.net. If you're looking for recommendation of what novels to read, you get a set of sliders: funny versus serious, beautiful versus disgusting, sexual content, no sexual or explicit, optimistic versus bleak. And as you move these, the covers change immediately, giving you clear feedback about what is possible, what the recommendation is. This has been done in many sites, like newspaper sites. You get sliders for politics, sports, and entertainment, and immediately the recommendations change on the screen. So you understand why you got a recommendations, because you favored politics or sports or whatever. And another example with music selection, Spotify has 14 attributes for each song, and these designers chose 5 of them: acousticness, instrumentalness, danceability, valence, and energy. You give the user control, they slide back and forth. The machine learning model gives you the results, and you can see where it goes. And there's another example from the OECD's Better Life Index, but I think you get the idea that slider control a priori, anti hoc, or prospective really does seem to be a more powerful way. Okay, so we come down to the end, and just this new world that we're approaching of human-centered human-centered AI. The summary says, that there are a rich set of things to consider. This is a complex environment where we have many layers of goals. We have strategies for accomplishing those goals. We think of the stakeholders, we consult with them, we observe them, we evaluate them, and we want to improve all of their performance. At the same time, we're aware of the threats that exist, of malicious actors, of bias in the data, or of software being flawed. And the way I organize it is to think about the 15 recommendations at these 4 levels of intervention: the software engineering team, which I focused on today; the safety culture for organizations, which you can read about; the trustworthy certification by external reviewers; and the role for software engineers here is to provide the data that's necessary in order to enable these independent oversight groups to work. And then the government regulation, which if done correctly, will stimulate innovation and protect public interests. So you can read more about them. The 3 key papers are here. These lay the foundations for the HCAI framework, the design lessons from the different metaphors, and then the 15 recommendations. There's 2 additional papers that I hope you look at, and overall there's information and further information about it on my website. But if you want to get in touch more, there's 3 ways you can join in the booming activity in human-centered AI. We have a Google group that you can join into. It's a once-a-week notice that goes Wednesday afternoons. A Twitter account you can follow, and a website which has some resources. This group is just a few months old. It's working its way forward. If you want to contribute and help us, that would be great. Send me an email and join the group and join this positive effort to make technology that really serves human needs. And that's the story. The future is human-centered. So that's where I come from. I'm happy to take your questions and have discussion. Thank you very much for your time and attention.
Thank you so much, Ben, for the great talk. It's really inspiring and it touched a lot of interesting and intriguing aspects. I just want to remind the audience that you could use the Q&A function of Zoom to ask questions. And we just realized that there's a bunch of people who is gathering on YouTube watching the live stream who are not on Zoom as well. If you're on YouTube, you will be able to ask questions there using the chat function. We'll monitor it and try to answer questions from there as well. So we do have quite a few questions from the audience. So the first question from Lilia, who is asking, are there third-party auditing agencies really trustworthy to assess AI systems? They have demonstrated time and time again to be corrupt and profit-driven.
Yes, they're imperfect like any human endeavor. And the famous stories of Enron and others show the failures of these systems. But you know, the Securities and Exchange Commission mandates that every publicly listed company, more than 10,000 of them in the US, have internal audits as well as external audits. And the Sarbanes-Oxley law reduced the dangers of corruption by requiring a strong separation between those companies that were consulting for the company and those that were doing the independent audit. Independent audit is a widely used practice in many disciplines for dealing with difficult issues. And Facebook's oversight committee, they don't call it independent oversight, but they do say oversight committee. And that group is, you know, we'll see how well that turns out, but it's a promising indication and recognition in the tech industry that some kinds of oversight are needed. So yes, I share your concern about any of these processes, but there's a long established, generally successful history of auditing being effective. Thank you. That was Lilia Brahimi.
Thank you. So the next question was about, I guess, the example that you give about on the explainability of the user interface. Hafed asked, the prospective user interface assume a linear model for mortgage eligibility, which may be not the case. Are you arguing that we should simplify the solution space in a suboptimal way just to get explainability?
Well, I don't see that it assumes a linear model. The case I showed was a very simple case, but these can be highly dynamic, nonlinear. They can you know, take in machine learning aspects as well, but they allow the user better control, just as recommender systems with sliders are based on machine learning, but then give the user a chance to explore. Now, you make the interesting question that, and the suggestion is, and there are many supporters of the idea that if you make it explainable, it will be suboptimal in its performance. And that is a myth. There's just no reason that should be. In fact, explainability is likely to improve the quality and accuracy of machine learning systems because the explainability reveals the hidden failures that are in these systems. Currently, the many failures in systems are just hidden because we don't see them. And in fact, the work at Google, Fernando Viegas, especially about visualization for machine learning, has shown dramatically that the visualization, not only of the neural network performance strategies, but also of the outcomes, reveal terrible mistakes in these systems. And the designers are the biggest beneficiaries. Giving them a visual understanding reveals problems, and so it makes systems better. Similarly, explainability, by exposing what's happening inside the system and letting the users and the other categories of stakeholders see what's going on, they suddenly begin to raise questions. They challenge what's going on. And that's very healthy for the machine learning community. You have to be open to the concerns that people have when they are affected by the systems you build. And that's one of the strategies. I might say, didn't go into it, but I talked about open reporting and incident reporting. You might want to take a look at the AI incidents database, at the Partnership on AI, built by Sean McGregor. It already has more than 1,000 stories and reports about failures of AI systems. And we have to understand those better. Only by having that kind of reporting can we build the safety culture that makes sure it happens. And that's traditionally what, in many organizations, the Food and Drug Administration in the US has an adverse drug event reporting system where thousands of reports come in from pharmacists, clinicians, nurses, and patients that report the kind of problems, side effects that they've had in taking different medications. That's the way we learn. We need to open ourselves to these things. So coming back to the explainability issue, the requirement for explainability adds challenge to the designers, but it's greatly advances the potential that the developers understand themselves. It explains it to the developers what's going on and where the flaws, non-linearities, and failures of systems may be. So the mathematical analysis done by really smart people that I have a great deal of respect for, which suggests that if you're going to make it explainable, you reduce the accuracy, I just don't buy. And I also go to Cynthia Rudin's approach, where she shows that the simplified, interpretable models are, if not the same, they're very, very close in their precision and accuracy to the obscure black box machine learning model. So I'm going to fight that one hard. Thank you for your question, but I really want to push back and suggest that explainability, visualization, openness, reporting, near misses, audit trails, that's the way we're going to get to reliable, safe, and trustworthy. Thank you.
Thank you. And the next question, I think it touched a little bit about the history of HCAI and also the new challenges that the AI system posed to the human-centered design. So it's from anonymous attendee. What are the key distinctions between human-centered AI and user experience? Could the difference be summarized to the integration of AI to user experience design?
I would say that human-centered AI is the happy intersection of user experience design and AI. And AI, which I said earlier, is devoted towards evaluating the performance of the algorithm, contributes very much. It brings us impressive performance in speech recognition and natural language translation, in sensor and signal analysis, one after another, really terrific, impressive analysis. At the same time, we need to bring forward and raise the human side, because those analyses need to be made visible and understandable to the very different classes of stakeholders. It's very different if presenting a user interface to a researcher, a developer, a business leader, and a user. Those are going to be very different user interfaces. So we need the methods of user experience design, which is observation, interview, survey of users, the study of users, the iterative design process, the usability testing, the iterative design, and the continuous refinement that brings out good systems design. At the same time, we need to bring the AI into play. And so the merger of these two approaches is where I think the high payoff is for both of them,
Thank you. There's actually an interesting follow-up. So Kateri, sorry for the pronunciation of the name, asked, putting many choices in the hands of people is of course good, but in the same time makes the configuration more and more complicated in complex scenarios. I suppose this would make most of the people to use the default configurations, which could still be biased. So the question is how to overcome this trade-off?
Yeah, very legitimate question. I would say the digital camera is your best example. In its simplest form, people pick up their phone and they turn on the camera and they point it and they click and they're done. And maybe 99% of the people use it that way, or 95%. Okay, but it's such a vast difference from the past where maybe 1 or 5 or 10% of the population were active in taking photography. Now we're at 95%. So that digital camera gives basically a default setting. And then there are dozens, overwhelmingly large number of choices that you can make before you take the photo. You can take a panoramic photo. You can take a square photo. You can take a slow motion video. You can take, all kinds of, you can have lighting settings, of portrait styles, etc. And those are amazing settings in advance. And then once you take the picture, there's dozens of settings you can alter: the contrast, the luminance, the brightness, and many other terms that Apple and Android designers have put into their cameras. And so there's a rich set of features. My approach to this is, you talk about a default versus others, but I would say a multi-layer structure that as a designer, you should think about, well, what's the default? What's layer 2? What's layer 3? What's layer 4? What's layer 5? What are the often main, the basic, the professional, and then the expert version or advanced version. So most media editing tools for music and video have 3 such layers. I've envisioned as many as 10 layers in some systems, where you would actually have a way you set the layers, and that reveals more or fewer commands. Almost every complex field, whether it's karate with 10 levels from white belt to black belt, or Suzuki violin, 5 levels, or scuba diving has 5 levels also. And so any complex technology should be presented in ways that I think are layered structured. I would say, while we have some examples of that, it's the single most greatest opportunity to improve design of systems, which often are overwhelming. Complex systems like Word or Excel or Photoshop are really challenging because they're presented all at once. Photoshop Elements simplifies it and gives you a simpler choice, but I think a layer structured strategy could become possible. And with even a slider along the side, layer 1, 2, 3, 4, 5, up to 10, where the user can choose what buttons are exposed for their use. So let me leave it at that. Other questions?
So yeah, I think the time is running out. I'm just picking one of the questions that is kind of different from the questions asked before. So Peter asked, machine learning systems also implicitly carry uncertainties in their predictions. How do you recommend we deal with that? People have trouble understanding the error estimates even in simple regression models.
Absolutely. Well, I think what you have to be guided by for using machine learning is the level of danger of an error. For machine learning, for recommender systems for books or films or restaurants, it's okay if it's not quite accurate and gives you something a little strange. It may even be fun and interesting and different. But if you're dealing with medical applications or transportation, you really need to have a much more careful approach. And that approach involves the software engineering strategies of extremely detailed testing in a rich variety of contexts and various manipulations of the machine learning training data, all those ways which we see, we see some of that, but I still want more of it. And then what we want is the incident reporting approaches so that errors which happen should only happen once. I think that's kind of the expectation, that failures happen only once. We learn from that and they can be fixed. And if the current systems don't provide a sufficient audit trail to find out why it went wrong and how it needs to be changed, shut it down. Okay, shut it down. You really want, for life-critical systems, medical, transportation, military, you really have to push for a much higher level of testing, confirmation, and continuous monitoring through audit trails. I think we've run out of the time here, but I've appreciated the questions and the opportunity to reach you. I see a good, strong audience here of more than 100 people, and I thank you for the time and attention. I've offered my slides to be posted, and the video will also be posted, I believe, for this. So I thank the team from SEMLA for giving me this opportunity, and I hope you'll all contribute. And please send me an email, join the Google group, follow us on Twitter, and visit the website. There's a lot happening here in a very short amount of time. It's an exciting time for me, and I hope for you too. Thank you.
Thank you very much.
Thank you so much, Ben.